Hello, my name is Iris, and today I will be teaching you about inflection point second derivative. When no one credited the introduction of the first derivative, the second one was introduced by Gottfried Wilhelm Leibniz. Now, what can this be used for? It could be used in business to analyze when products slow down or accelerate. In stocks, it can be used to find a turning point. In economics, it is used to pinpoint when technology disrupts the market. And in physics, it could be used to identify points when acceleration changes. Now, the definition of this would be a point where the concavity changes and it is identified by finding where the second derivative of the function is equal to zero or unidentified. That is our definition. Now, what does it look like? Well, it could be something like this, where it has concavity down and concavity up. That's how it's supposed to look like. That's in the graph form. That's the simplest way. Now, let's get straight to an example. Now, our first equation would be x cubed minus 9x squared plus 7x. We find the first derivative of this would be 3x squared minus 18x plus 7. And our second derivative would be 6x minus 18. We simplify this, would be 3, 6. Now, this equals 3, and we have to find a number that is bigger and smaller than the 3. So we have to choose easy numbers to make this simple. We choose 4 and 2. Now, we plug in these two numbers into this x right here. So it'd be 2 minus 3 equal negative 1, right? And we multiply it by the 6, which equal a negative 6. This means it's concavity down, so we put a negative right there. Now we plug in the 4 into the same x. So 4 minus 3 equals positive 1, multiplied by the 6 equals positive 6. So that's concavity up. Now we write it down. Concavity down would be from negative infinity to the 3. So 3. And then concavity up would be from the 3 to positive infinity. Those are our concavities, which means, oh my god, my pen. Our graph will look similar to what I drew, but 1, 2, 3. From the 3, it changes, you see? Now, to find our IP or inflection point, we have to plug in the 3 into our original equation. So it'd be 3 cubed minus 9, 3 squared plus 7, 3. Now this equals 27. This equals 81. And this is 21. Now we get 33, right? So our IP, or inflection point, is the 3, because that's our x, and our y would be 33. That's our inflection point. So that's how we get the first one. That's our answer right there. So moving on to our second example. Second example would be 2x cubed minus 3x squared. That looks like a 6. That's supposed to be an x. Okay, minus 12x. First derivative would be 6x cubed minus 6x minus 12. Now we do our second one because we're looking for the second derivative, which would be 12x minus 6, right? We take away a 6 from it. We simplify 2x minus 1. Right, we do the math. So it would be 1 over 2, or 1/2, right? So our 0.5, because that's our half, let's choose a number that's bigger than it and a number that's smaller. So easy numbers, 0 and a 1. We plug into 0 to that, so it'd be 2 times 0 minus 1. This equals 0 minus 1 stays. This would be a negative, or concavity down. Now we have a 1, we plug it in there too. 2, 1 equals 2 minus the 1 is still positive because it'll be positive 1. That is our concavity up. So concavity down from negative infinity all the way to our 0.5 or 1/2, and concavity up would be from 1/2 to infinity, positive infinity. That is that answer right there. Oh man. Now, to find our IP, we have to plug in the 0.5 into every single 1x. Right, so it'd be 2 1/2 cube minus 3 1/2 squared minus 12 1/2. Right, so this would be 0.25, negative 0.75, and negative 6. So we add all these together. Since these are negative, they team up against that. So we'd have 6.50 negative. So our IP would be 1/2. And then our y would be 6.50. Again, our graph will look something like that, right? Not to say about our points because I haven't plugged them in yet, but that would be our answer right there. Now, I chose this topic because I thought, well, I didn't think I was having trouble in it in class. Sometimes I still don't understand it. I had trouble, but I think I understood it a little bit more now, teaching it to myself and trying to explain it out to people. I don't have trouble with that, so yeah, it's still math. I love it, but thank you so much for watching.